This is section 5.04 of Unit 5 Notes, Expected Value. Today I am, as in you are the student, discussing expected value so that I can create, analyze, and interpret probability distribution. I will know I have it when I can successfully solve expected value problems. Specific TEKS we're looking at for today's lesson is 8C. Probability distribution. A probability distribution shows the probabilities of every possible value of a random variable. Each probability is a number between 0 and 1. So for example, 1/2, 3/4, 1/8, 4/8, 5/8, 0.17, 0.106, 0.98, 50%, 51%, 48%, 99%. Those are all examples of numbers between 0 and 1. In a probability distribution table, you can show the possible outcomes of x, the random variable, and write the corresponding probabilities, p, as fractions, decimals, or percents. The sum of all probabilities is equal to 1. So, probability distribution table organizes all the possible outcomes of the random variable into a chart and shows you what those probabilities are for every single one of them. And when you add up all the probabilities together, it should total up to 1. Before we we understand how to make a probability distribution table, let's talk about what are examples of wrong distribution tables or bad distribution tables, and what's an example of a good probability distribution table. So, there's two conditions that need to be met. Each probability is a number between 0 and 1. The sum of all the probabilities is equal to 1. Those are the two conditions that must be met. So, what is wrong with each probability distribution table? Let's take a look at the first. We have 4 different colors: blue, orange, green, and purple. We have the numbers 0.3, 0.4, 0.5, and negative 0.2 respectively. So, first, is each probability a number between 0 and 1? No. The issue is with purple. There are no possible negative probabilities. Negative probabilities do not make sense at all. There's no such thing as a negative probability. Therefore, that is the issue. Now, when you add them all up, 0.3 plus 0.4 plus 0.5 plus negative 0.2, they do total up to become 1. But, again, the negative value is the issue. Both conditions need to be met, that they are a number between 0 and 1, and that the sum of all the probabilities is equal to 1. Both need to be correct, or both need to exist in order for it to be a correct probability distribution table. Again, that's why this one is wrong. Okay, let's look at the second one. Let's see what issues we have with this one. Is each probability a number between 0 and 1? Yes. 0.4, 0.4, 0.2, 0.1, those are all numbers between 0 and 1. However, let's add all these up and see if they are equal to 1. 0.4 plus 0.4 plus 0.2 plus 0.1. 1.1. It needs to equal 1 exactly. It can't be a little bit over. It can't be a little bit under. It needs to be exactly 1 when you total them up. Therefore, this is incorrect. The sum of all probabilities is 1.1 when it should be 1. Let's look at the third table. 0, negative 1, 1, 0. We already have an issue here. Orange cannot have a negative number. So, that is the issue. Orange has a negative probability of -1, which doesn't make sense at all in the world of probability. All right, so those are all examples of bad probability distribution tables. Let's look at an example of what is a good probability distribution table. So look at each of these numbers. Are these numbers between 0 and 1? Yes, 0.6, 0.05, 0.05, 0.3. Those all look good. Now the second condition, are all of these, or when you total them all up, does it equal to 1? So 0.6 plus 0.05 plus 0.05 plus 0.3. Yes, they total up to 1. So this is an example of a good probability distribution table. All right, now let's talk about how to change probability distribution table, or sorry, a frequency table into a probability distribution table. So let's look at this example. A coin tossed twice will result in one of the following sequences. So I get heads, heads after tossing a coin twice, heads, tails, tails, heads, or tails, tails. X represents the number of heads for 2 tosses in this frequency distribution table. So this table reads from the start on the left, what if we had 0 heads? Well, of the possible outcomes, there's only one of them with the probability of 0. Oh, I'm sorry, one of them that has an outcome of 0 heads, not probability. How many have an outcome of just 1 head? Well, that's either heads, tails, or tails, heads. So there's 2 possible ways of getting that outcome. So what's the possible? How many outcomes do we have for getting 2 heads? There's only one outcome for that, and that's heads, heads. Now the total that we have from this frequency table is 4. That's going to be important in a little bit. Okay, so again, 0 heads we have 1 outcome. 1 head we have 2 outcomes. 2 heads we have 1 outcome, and we have a total of 4 different outcomes for this frequency table. One of the problems you're going to encounter is how do we change a frequency table, which we've learned in previous lesson. How do we change a frequency table into a probability distribution table? Well, let's take a look. I'm going to cover some of these and then reveal them as we go. So first off, using the frequency table, let's change every single one of those values into probabilities. So what's the probability of getting no heads? Well, the probability for that is 1. I'm going to show you what numbers I'm using. 1 out of 4. So 1 out of 4 chances you're not going to get double heads in your coin toss. So as a decimal, it's 0.25 when you divide that. And just to show y'all, in case y'all didn't know, 1 divided by 4, 0.25. So now, what's the probability of 1 head? Well, there were 2 possible outcomes. Heads, tails, or tails, heads. Again, 2 possible outcomes. So 2 out of 4 are going to be 1 heads. 2 out of 4, which turns into 0.50 as a decimal. And then finally, what's the probability of 2 heads? Well, you got 1 of the outcomes out of 4 where you can get double heads. That's right there. So 1 out of 4 will give us 0.25 as a probability. Okay, now changing this into a probability distribution table. X is the random variable. The random variable in this case is the number of heads for two coin tosses. P instead of F now is the probability. So we're not looking at frequency anymore. Frequency is the amount of times it occurred. P represents probability. What is the chances of getting said outcome? So now 1 changes to 0.25, 2 changes to 0.5, 1 same thing. When you total all of this up, your probability distribution table should always be 1 if you did this correctly. And here is the table. The frequency table changed to a probability distribution table. What's the probability of getting 0 heads? 0.25. The probability of getting 1 head? 0.5. Probability of getting 2? 0.25. Instead, frequency table says, how many times did you get 0 heads? 1. How many times could you possibly get 1 head? 2. How many times could you possibly get 2 heads? 1. So those are the differences between the two. So here are the steps, which we'll talk about in another example. Find the sum of the frequencies. Divide each frequency by the sum. That's what we did right here. Each frequency was divided by 4 to get this fraction. Change the fraction to a decimal. Put the answer in the probability distribution table, and then check yourself. Step 4. Add them all up. If you got a total of 1, then you did this correctly. So let's look at this you try. A fire department recorded the number of fires they put out each day for a season. The results are shown in the table. Convert the frequency table to a probability distribution table. Here are the steps. You're going to start here on the frequency distribution. Step 1, find the sum of the frequencies. So total up all the frequencies, put it in the box right there. That's step 1. Step 2, divide each frequency by the sum. And you're going to type that in right here to get your fractions. And then give me your decimal answers in step 3. Change each fraction into a decimal. Then type each decimal into the probability distribution table. Excuse me. Step 4. Check yourself by adding all of the probabilities. If they equal to 1, you did this correctly. And then if you want to check your answer, just scroll down if you're on ClassKick doing the notes as you're watching the video. Look at the box and see if you're doing everything correctly. Or move the box and then look behind it to see if you're doing everything correctly. So go ahead and try number 1. See if you can figure this out on your own. Otherwise, I'm going to go continue on and show y'all how to do this. So we have frequency distribution table, which says how many times did this fire department have 0 fires? 58. How many times did it have 1 fire? 10. How many times did it have 2 fires? 8. And then how many times did it have 3 fires? 4. Within a certain day. So first off, what is the total frequency that we have in this table? We're going to add all those values up. 58 plus 10 plus 8 plus 4. 80. We have a total of 80 fires in this problem. Use a different color here. 80 fires. Now, I want the probabilities. So I'm going to divide each one by the total frequency to get their probabilities. Well, what's the probability of having 0 fires? For this experiment, or for this data, 58 of those fires out of 58 days were without any fires out of the 80 days that they worked. So, what is 58 divided by 80 as a decimal? 0.725. So that is the probability in decimal form, 0.725. What's the probability of they had to deal with one fire? Well, out of the 80 days, 10 of those were only 10 of those days they only had to deal with one fire. So 10 divided by 80, I believe it's 0.125, but I'm going to check. Yeah, that's right, 0.125. So this is the probability of only dealing with one fire. What's the probability that they will be dealing with two fires on any given day? Well, that's 8 out of 80. Divide that, I believe that's going to be 0.1, but let's check. That's correct, 0.1. And then what's the probability that they will have to deal with three fires in any given day? 4 out of 80. Now, I wonder if that's 0.5. 4 divided by 80. Yep, well, I'm not 0.5, 0.05. But there it is. So now I'm going to take each one of these and then apply them to the probability distribution table. 0 is 0.725. 1 is 0.125. 2 is 0.1. 3 is 0.05. So again, the probability distribution table reads, what's the probability that the firefighters will have to deal with 0 fires? Well, 0.725 probability. What's the probability that they'll have to deal with 2 fires at any given day? 0.1. Versus a frequency distribution table, which tells you how many days did they have 0 fires? 58 days. How many days did they have 2 fires? 8 days. Those are the difference between the two tables. Now, as a final check, I'm going to add all these up. 0.725 plus 0.125 plus 0.1 plus 0.05. Total should give you 1. If that's what you get, then you created the probability distribution table correctly. That's it for you try number 1. Okay, another example. You try number 2. So, which probability distribution table corresponds with this frequency distribution table? So, here's the table, frequency distribution table. See if you can work everything on your own using the steps that we did in the previous you try number 1. And then choose the correct letter answer. And then type your answer right here. Show your work if you can. Follow the steps. If you need to see if you're doing everything correctly, if you go to the next page on ClassKick, you can move that box to see if you're doing everything correctly. But all right, at this time, I would like for y'all to pause the video, try this problem on your own. Otherwise, I'm going to continue on and show y'all how to do this. So, which probability distribution table corresponds with this frequency distribution table? So first off, we're going to find the sum of the frequencies. Frequencies being F. We're going to add 11 plus 1 plus 2 plus 4 plus 2. So 11 plus 1 is 12. 12 plus 2 is 14. 14 plus 4 is 18. And then plus 2 is 20. I'm then going to take every single one of these and divide them. And that'll give me my probability. So divide each frequency by the sum. And then that will be my probability. 11 divided by 20 should be 0.55. 1 divided by 20, I believe, should be 0.05. Yes. And then 2 divided by 20 should be 0.1. 4 divided by 20 should be 0.2. And then 2 divided by 20 should be 0.1. Let me make sure for each one of those. 2 divided by 20, 0.1. And then 4 divided by 20, 0.2. Yeah. Now, I'm going to add all these together. Make sure I did everything correctly. 0.55 plus 0.05 plus 0.01. I'm sorry, plus 0.1. And then plus 0.2 plus 0.1. Which totals out to become 1. So everything, as far as I know, is done correctly. Now, if we're having a multiple choice, let's check the first one. See if we have what we need. A does not match. We know that doesn't work. B does, so that's a possibility. C does not match. D does not match. So the only one that makes sense in this case is B. B is the final answer. That's it for you try number 2. Yeah, and there's just an explanation right there why B is the right answer. So y'all can just go through that and see if you can follow along. Otherwise, that's it. Okay, so some other problems involving probability distribution table. To find how many the probability represents, we're going to multiply the corresponding probability P by the total number. So sometimes we want to we're given a figure. From that figure, we also have a probability distribution table. We want to figure out from that figure how much of a certain area, certain event comes from a specific thing. So, for example, there are 24,200 residents in the city. How many live in the central region? We have a figure. We also have the probabilities of individual regions that they probably live in. So we want to figure out how many live specifically in the central region. Well, we know the probability in this example, according to the table, is 0.44. 0.44. So how do we find out how many residents live there? Well, we're going to multiply. We're going to multiply 24,200 times that probability, which is 0.44. And we have 10,648 people, residents, that live in the central region. That's it. That's the answer for this example. Okay, you try number 3. Same type of problem, except now I want you to do this for the South. How many live in the South region? Again, get your total number, multiply by the probability for said region, and then get your final answer. Move the box to see if you're doing everything correctly, and check yourself. So, at this time, I would like for y'all to pause the video, try number 3 on your own. Otherwise, I'm going to continue on, show y'all how to do this. All right, South. Probability that somebody lives in the South is 0.14. Well, so how many residents from the 24,200 does that make? Multiply the two. 24,200 times 0.14. 3,388. So the amount of people that live in the south region of the city is 3,388. That's it for you try number 3. Okay, here's another example that you'll run into. To find the probability of one event or another, again, one event or another, add the probabilities from each event. What is the probability that a person lives in the east or west region? So east and west region are highlighted here. 0.12 plus 0.18 gives me a total probability of them living in the east or west of 0.3. You just simply add those two together. 0.12 plus 0.18 gives me 0.3. That's it for this example. You try number 4. What is the probability that a person lives in the north or south region? Go ahead, try this problem on your own. Again, add the probabilities for each event if we're trying to do one or the other, and then total them up to get your final answer. Move the box if you want to check yourself if you're doing this problem on ClassKick. Okay, so go ahead and pause the video, try this on your own. Otherwise, I'm going to show y'all how to do this. So, what is the probability that a person lives in the north or south region? Add those two up. 0.14 plus 0.12, which will give us a final answer of 0.28. The probability that they live in the north or south is 0.28. Oh no, sorry, not 0.28, 0.26. I did that wrong. I'm glad I looked at the answer to check myself there. I probably should have done this in the calculator instead of relying on my head here. 0.14 plus 0.12 gives me 0.26. There we go. That's it for you try number 4. All right. Expected value. Expected value. Expected value is the mean of the probability distribution, the average of a probability distribution table. To find the expected value, multiply each outcome by its probability, and then add the results. So in this scenario, we've already done this before. So we're going to continue on from a problem we did a few slides ago. Right here, I believe. So, a fire department recorded the number of fires they put out each day for a season. Using the probability distribution table we made earlier, find the expected value. So, this part we don't exactly know yet. I'm going to reveal it as we go. We found that the probability that the firefighters will have to fight 0 fires is 0.725. 1 fire is 0.125. 2 fires is 0.15. 3 fires is 0.05. So what we're trying to find out is how many fires can they expect to put out at any given day. We're going to find that average. And we do that by multiplying the X value and the probability, the P value. So we're going to multiply all of these together. 0 times 0.725 is 0. 1 times 0.125, 0.125. 2 times 0.1, I believe is 0.02 or 0.2. There we go. 3 times 0.05. 0.15. Now we're going to total that column right there, x times p. 0 plus 1, 0.125 plus 0.2 plus 0.15 is 0.475. This is the average from the probability distribution table. What does this mean? What does this average tell us? What did we just calculate? The average amount of fires the fire department can expect to take out at any given day is 0.475 fires. Now, you can't really have 0.475 fires in reality. So the way you interpret this is, more often than not, since it's below the halfway point, you can expect them to either to not have to put out any fires, or have to at least put out one fire, since it is above 0. So at any given day, they can expect to take out one fire or no fires, with it leaning closer to no fires per day. So that's how you interpret this number. That's it for this example. Okay, you try number 5. So now, I've added a little bit more difficulty to this. I now want y'all to construct the entire table and then find your final answer by doing the steps that we did from the previous problem. Okay? So, a small train at an amusement park is carrying passengers. Half of the passengers are 4 years old, 2/5 are 5 years old, 1/20 are 6 years old, and 1/20 are 7 years old. What is the expected age for one of the passengers on the train? Step 1, fill out the table. What are the x values? In this case, the age is the x values. What are all the probabilities? Make sure you enter the p values, the probabilities, as decimals. Multiply those two together to get your third column, x times p. Add them all up, and then that'll be your final answer. Okay? And if you want to check yourself, I have the table right here for you to check to see if you did everything correctly. So go ahead, pause this video, try this on your own. Otherwise, I'm going to continue on and show y'all how to do this. Step 1, what are the x values that I'm dealing with? So I'm dealing with ages of 4, 5, 6, and 7-year-olds. So I create a table where age is x, 4, 5, 6, and 7-year-olds. The probability of 4-year-olds is half. Half of them are 4-year-olds. So as a decimal, that's 0.5. Again, I want the decimal form. Half is also 1 divided by 2. 1 divided by 2 in decimal form is 0.5. 2/5 are 5 years old. So 2 divided by 5, that's 0.4. 1/20 are 7 years old. 1 divided by 20 is 0.05. And then 1/20 are 7 years old. Did I say 1/20 are 6? I think so. But 7 years old is the same probability, 0.05. Now, I'm going to take all these values, multiply them together. Four times 0.5 is 2. 5 times 0.4 is 2. 6 times 0.05 is 0.3. 7 times 0.05 is 0.35. Add all these up 2 plus 2 plus 0.3 plus 0.35. 4.65. So what does this mean? The expected age for one of the passengers on a train is 4.65 years. So the train conductor, when boarding all the passengers, can expect the age of that person to be about 4.65 years, the average age of passengers boarding this train. 4.65 years old. Let me check just to make sure, and yes. That's it. That's it for you try number 5. Okay, that's it for this lesson. If you have any questions, let me know. You have my phone number and email right there. After 5 p.m., which is when I'm not working, you could always use my phone. Don't expect me to answer, but if it's an emergency, if y'all do really need help right there and then, I'll try my best to answer there. Otherwise, just email me and I'll get back with y'all as soon as possible, okay? That's it for this lesson. Y'all have a good one. Take it easy.